Hello everyone, myself Sindhishri. I'm currently pursuing my third year engineering in Sri Venkateshwara College. So today we're going to discuss about the data classification used in computer graphics. So data classification is the foundation of efficient data processing in computer graphics. It involves organizing and structuring visual information and initiative retrieval, analysis and manipulation of the graphic assets. Next, the two different types of data are raster data and vector data. Raster data, pixels arranged in a grid capturing the exact visual details, useful for photorealistic imaginary but less scalable. In vector data, mathematical descriptions of shape and path, scalable and resolution independent, ideal for graphics like logos and illustrations. In raster data, it is typically used for continuous data like satellites, images, aerial photographs, and digital evaluation models. Vector data is an ideal for representing discrete data such as boundaries, roads, and specific locations. Example for raster data is digital photos in scan maps, and example for vector data is city maps with the road networks, property, boundaries. So basically raster data are been arranged in pixels and vector data has been described using a mathematical equations, shapes, and paths. Next, the other two types of data are structured and unstructured data. In structured data, it is organized in a predefined format like 3D models or animation files, enabling efficient retrieval and processing. And unstructured data, free from visual assets like images and videos, requiring more data classifications and interdependence. So structured data stands for information that is highly organized, factual, and to the point. Unstructured data is any predefined structure to it, does not have any predefined structure to it, and comes in all its diversity of format. So structured data is a quantitative data and unstructured data is qualitative data. Structured data, where the data warehouses is relational databases. So data takes non-relational databases. Structures have several predefined formats. Unstructured has a huge array of formats. Next, the other type of data structure is spatial data structure, which contains quadrats and quadtrees. Quadrats are tree-like data structure that recursively divide 2D space into 4 quadrants, enabling effective spatial queries. And octrees, it is a 3D extension of quadtrees, partitioning space into 8 sub-volumes useful for 3D graphics. And point cloud. Now let us discuss about the hierarchical data representation. At first is level of detail and the second is scene graphics, third is image pyramids. Level of detail, it stores the data and multiple resolutions to enable efficient rendering and progressive loading. Second one is scene graphs. It is a tree-like structures that organize 3D scenes allowing for initiative manipulations and traversal. The last is image pyramid, sequence of downscaling images, facilitating the fast access to different level of detail. The above figure shows how the level has been classified. In first level, the root node or the root node will be present, and then in the second level, the parent a child of those root nodes are present, and in level 3 it contains the data, all the data required collected or retrieved. Next, let us discuss about indexing and retrieval of graphic data. At first, querying. Efficient search and retrieval of assets based on metadata, content or spatial properties. And second one is indexing. Creating data structures like R trees and KD trees to organize and index graphic assets. The last is asset management, maintaining comprehensive catalogs of graphic data to enable easy browsing and discovery. Now let us see the techniques for efficient data processing. The first step for data processing will be a parallel processing. It is a leveraging multi-core CPUs and GPUs to accelerate tasks like rendering and simulations. In parallel processing, we can stimulate 2 or more CPUs to run the multiple programs at the same time. The next one is compression, applying lossless and lossy techniques to reduce the size of graphics assets without compromising quality. So we have to apply the lossy techniques, that is each of the files should be independent to each other. Changes made in one side should not difficult on the other side. We have to compress the file in such a way that its quality should not be damaged. The last is optimization. Techniques like culling, level of detail, and caching is to minimize the process requirements. Then, as the last step, we have to optimize the data. If we have obtained small data, we have to optimize it to get a proper output. Now, let us discuss about the challenges and future directions. So, increasing data volumes, and next is real-time processing, and the last is machine learning. So, increasing data volumes, managing the exponential growth of graphic assets from high resolution 3D model to vast image and video libraries. Last one is real time processing, enabling instant access and manipulations of large scale dynamic data for applications like virtual reality and gaming. The in the machine learning, leveraging AI techniques for intelligent asset classification, retrieval, and generation, visualization, graphic flows. So basically, in increasing data volumes, we have to collect the data to be in a large volume to build a model or some to resolve for high resolutions. And then we have to use real-time processing so that the data should be visible, or it can be modified by the user also. It should be a real time which has used in day-to-day life. And then machine learning, we learning AI techniques. Here we learn AI techniques and intelligent assets, and then classification, retrieval, and generation, revolutionizing graphic workflows. Next, thank you.